Hey Math 30-2 and welcome to lesson 1.3. This one is going to be on intersection and unions of two sets. So let's get started. So we're just going to kind of go through these questions and put them in set notation, and we're going to come across how to start writing this stuff. So number one says all the numbers we'll be using in this question are the integers from 1 to 10. So that's talking about our universal set. So I'm just going to say u and write this in set notation. So integers from 1 to 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's my universal set. The first set, set A, are the numbers from 1 to 5. So we say A, and then in set notation, 1 to 5. Okay, the second set, which we call B, is going to be 3 to 9. So there's some overlap here, right? So B is going to be 3, 4. Okay, so that's kind of where we're at so far. We got those two sets. We can tell that they're going to overlap, right? And let's just go ahead and put our numbers in this top box here too, so we can kind of get a feel for what's happening here. So in just set A, we're going to have 1 and we're going to have 2, right? In our middle section, ones that are common to both are going to be, well, 3, 4, and 5, right? They're common to both. So they're going to have to go in our middle section. I'll make them red too so we can kind of see. So 3, 4, and 5. Now in just B, well, that's going to be everything that's left. So that's going to be 6, 7, 8, and 9. Okay, so now number 4 says all the elements of A and all the elements of B. Show this in set notation and shade the appropriate region. So some of you guys I've been talking to already and saying that, okay, when it says or, then it's talking about everything. So this is all the elements of A and all the elements of B. We are talking about everything. So if you're going to shade this, this would be all of it. And now, how would you show that in set notation? Well, that would be A union B. So that's our new thing. This should be like a U. I know I'm kind of bad at that sometimes, but it's saying like A union B. And union means kind of think about like, I don't know, like two married people, right? They come together in union, so they become like one thing, right? You if you're married, you're now like one entity. That sounds cheesy, but anyway, so it's all of it. So union is both of them together, like everything that's there. So you'd say A union B, and then just do the same thing, but then it's going to be your universal set. It's going to be all your numbers because it's all of them from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Ooh, but actually, I just kind of noticed here, it's not 10, right? Because B, if we look back up here, it only went to 9. The universal set went to 10, so these things actually don't have all of the universal set in them, so it just goes up to 9. So, and there just wouldn't be a comma after the 9 there. Okay, so now it says for number 4, elements that are common to A and B. So these are key words. So A and B. Show this in set notation and shade the appropriate areas. So and A and B, that's going to be where they overlap. That's where they're both going to have those numbers in common. And let's go back for a second and let's write down just so we can kind of keep track of things, right? Union. This is an example of a union. And maybe draw like an arrow to that thing and say union, right? That's what that last one was. This one is now going to be A, but instead of a U, it's going to be an upside down U. So it's going to be A intersection B. So maybe write down intersection like I've done there, and maybe over here too to show this is an example of an intersection. Maybe write it nicer than I did. All right, so it's going to be A intersection B, and then just put the numbers that are going to be in the intersection of B. So if you look back up here, those were my red numbers up here. Right? That's where they intersect. So it's going to be 3, 4, 5. All right, now let's keep moving on. So 6 says the elements that are in A but not in B. So if we kind of it's kind of easier with that picture here. We can kind of see what that looks like. Let's make that red maybe. That's going to be all of this area, right? So all of that. That like crescent moon type of a thing, or like a Pac-Man looking shape. So how do you write this in set notation? Well, there's no actual like really easy way to like, straightforward way like we kind of had up here with union and intersection. The way we have to do this is we have to say, okay, we're going to call this red area as if we took all of it, so that whole blue area, right? So A union B, and then just subtracted B, right? Because if we had like this area, this thing up here that was fully shaded, and then just subtracted all of B, like took all of that red away, what you'd be left with is what we kind of have here. So what we're gonna do to write this in crap. What we're gonna do here, I'll do that again, is write it as, I'm gonna put in brackets and say A union B minus, well, minus B, right? That's how we got that like leftover red area. So minus B. And then that's going to be equal to only those things that are in that red area, which was just 1 and 2. That one, right? So you'd say that's equal to 1 comma 2. Okay, let's keep moving on. So 7 says the elements that are in B but not in A. Show this in set notation, shade, yeah, so same thing. So elements that are in B but not in A. So we've kind of just got the opposite type looking thing here now, where it's going to just be this over here. So it's going to be that one. So really similar as the last one. So we're going to start off with A union B, right? All of it. We're saying like take the entire thing, like A and B together, and we're going to subtract. Well, what would we subtract this time? Well, to get just that purple area, what we had to do was subtract all of A. We had to subtract all of this stuff, right? To get that leftover bit. So what we're going to say is that minus A. And then lastly, just kind of put the numbers that are actually in that purple area. So if you want to, you can go back up to your original one. That was 6, 7, 8, and 9. Okay, now 8 says the elements that are not in A. All right, so not in A is going to look like, well, just everything other than A. So that's going to be everything in my universal set and everything that's in this only B part of it over here, right? So it's all of that. That's the shaded area that we're kind of talking about here. So everything not A. Well, we have a name for everything not A. We call that A conjugate, right? That A dash there. So now A conjugate, if you want to make sure you know what that is, well, that's everything but 1 and 2, right? So I can just go ahead and write everything else in my original universal set up here but 1 and 2. So 3 to 10. Whoop. Okay, the shaded area, or the shaded elements that are not in B. So we got this similar type of thing happening here, but everything but B. So that's going to be all of this. Everything but that circle B. Okay, so we have a name for that. It's called B conjugate. Everything but B. So if you want to now look back up to your original one, say, okay, everything but B, well, that's going to be 1 and 2, and then just don't forget 10 on the end. So it's going to be 1, 2, and 10. Because remember, 10 wasn't part of either. 10 would be like sitting outside, out here, down like outside of those circles. Okay. The elements that are not in A or B, show this in set notation and shade the appropriate area. So not in A or B. So everything not in here. So that's going to be all of this shaded area. So everything outside of those. So all of that. Okay, and the way we do that is, well, everything, like if I would take this red area, this would be A union B, right? All of that would be A union B. So I'm just going to go A union B, and then just go, well, the conjugate of that. Everything but A union B. And then there's only one element in that. There's just the element 10. That's it. Okay, so let's move on to the next one here. Okay, so for this one, I'm gonna get you guys to go ahead and give it a try on your own. So you're gonna need to go to page 22 in your textbook and read through that question. And then for that one, just letter A tells you what to do for these. So set T is going to represent all of the hourly times from 1 to 24. So you really, if you wanted to, you could write it like just 1 and then, all the numbers up to 24. Or you could write it like X, where X is going to be greater than or equal to 1, and it's going to be less than or equal to, what was it, 24? And then where X is any natural number. Okay, and then probably for R and L, you probably just want to put the numbers that were in there instead of writing it in this kind of method. So go ahead and I'll let you guys fill those in. I'll let you put the numbers in there as well. And then when you're done that, go ahead and, well, push pause, sorry. Go ahead and do that, and then I'll pop the answers up at you in a minute. So go ahead and pause the video now. Okay, so I didn't want to write it all again on the other sheet, so I'm just going to kind of go out the key I have here. So you can see that was my sets for R up here, my sets for L, or the elements in that set. And then, so R, you can see these elements I got, the overlapping ones. I just kind of circled them in here to see which ones would actually be overlapping, and then threw them in the middle. And then, yeah, so that's kind of what I got. T, those are the leftover ones that didn't make it into sets L or R. And then I'll go through the other ones with you. So it says now list the elements of the complement of the union of R and L. So remember R union L, that would be everything. So we're talking about all the numbers in here, right? So the complement's going to just be all the leftover numbers, right? Everything outside that are inside, universal set, but not part of those. So that's all these numbers along the side here. That's what these are. Okay, so this says complete each statement with and or. So the set R intersection L, right? Not a U, it's upside down. That's an intersection L. Consists of the elements in set R and set L, right? The ones that are in the middle here. That's what it's talking about when it says and. So and is that middle one. And then the set R union L consists of the elements that are in set R or set L. So that would be everything that's in both of these circles. Okay, so D here says the number of elements in R union L, so, everything. So it's saying the number of elements, the number of things that are in this whole shaded area, does not equal the number of elements just in R. So if I took just this, all the ones in R, and added together all the ones in L, so added together all of that, it doesn't equal the two of them together. That's pretty much what this is saying, right? What does it equal? Can you make an equation to represent this number using set notation? Okay, so the way this is going to look is we're going to have, if you look at R here, the number of elements in R plus the number of elements in L is going to give you more than the two of them together. And how much more? Well, it's going to be the middle section more. Because really what's happening is if you take this red circle and you added this green circle, you've added the middle section twice. It's like you've counted it twice, right? So what you have to do is just like subtract that middle section from it. So the equation for this, you could say the number of elements in R, so that's the way you'd write that too, right? Like N and then bracket R, you're saying the number of elements in R plus the number of elements in L is going to be equal to um, the number of elements in R union L, right? All of it together. But we're saying it doesn't equal that. It's going to equal that plus that middle section, right? Like I said, we counted that middle section twice when you added those together. So it's going to be that plus n number of elements in R intersection L. That's what the middle area is. Okay, so that's kind of our equation. Hopefully that made sense. And now I'm just going to write this a little bit different. I'm going to write this as n R plus n number of elements in L. And now I'm going to subtract this from both sides. I'm going to go minus R intersection L from both sides. And then bringing it over here, right? So I'm just rearranging this equation. So I'm going to say minus n number of elements of R intersection L. That's going to be equal to the number of elements in R union L. So what we have right here, this is what's called the principle of inclusion and exclusion. I know it's a long name, but I had to write that underneath here. So that's our principle of inclusion and exclusion. All right. So let's start to kind of use this new language that we've kind of developed here. So example 1 says, if you draw a card at random from a standard deck of cards, you will draw a card from one of 4 suits. So you're either going to get a club, a spade, a heart, or a diamond. We're going to call that C, S, H, or D. Okay, now it says determine the number of elements in C, so clubs, number of elements in each one of these things, right? And number of elements in the universal set. That's what NU stands for. So the number of elements in the universal set, well, that's going to be how many cards there are in a deck, right? So the number of elements in the universal set is going to be 52. It's 52 cards in the deck. Number of elements in clubs, well, that divided by 4. There's a quarter of that many, so there's going to be 13. And that's going to go for the rest of them too, right? They're all even. So number of elements in spades, 13. Number of elements in hearts is 13. And number of elements in diamonds is also 13. Okay, so determine the union of S and H. Determine the number of elements in S union H. Okay, so let's kind of think about what that looked like for a sec. If you're going to draw that out, really none of these circles are going to overlap, right? This is going to be my spades and this is going to be my hearts. They don't share any of the same cards, right? So they don't overlap at all. The union still is going to be all of them though, right? It's going to be both of them all together. So union's everything together. So that's just going to be all of them, right? So that's going to be this entire row of, what was it, spades? So all of these and all of these. So I'm not going to write them all out because I'm kind of lazy right now, but let's just say it's all of those. So the number of elements in each one, or for that, so N, the number of elements of S union H, well, that's just going to be 13 times 2, so 26. Describe the intersection of S and H. So it's really saying how many cards are in where they overlap. Well, they don't overlap. They don't overlap at all, right? There's nowhere that they intersect. So there's 0. There's nothing in that set. Or there's gonna be no cards in there. So we'd say N S intersection H is equal to 0. There's 0 in there. Notice that I'm not putting those squiggly brackets on it like that or anything, because when I say the number of elements in here, I'm not like actually putting the numbers in there. I'm saying how many individual ones are, right? Like I'm not writing out all the numbers that it could be. So you just say is equal to 0. Just like we did up here. I said there was 26 cards. I didn't list all of those cards like we would before, right? When you're saying the number of elements in there. Okay, so this one D says determine whether the events that are described by set S So spades and hearts are mutually exclusive. So there's a new word. Mutually exclusive just means that one doesn't affect the other. So yeah, they don't, right? If I pick some spades, it's not going to affect the hearts, right? So that's just kind of like a it's going to be coming around the corner. We're going to talk more about that, but for now, we're going to say that yeah, they are mutually exclusive, and whether sets S and H are disjoint. So remember, disjoint just means that they are not joined. So disjoint sets, yeah, they're not joined together. So both of those. So they are mutually exclusive and they are disjoint. So I'll let you guys write that down. Okay, now it says describe the complement of S union H. So S union H, maybe I'll put brackets around it and a little dash to say the complement. Well, I know what that's going to be equal to because the complement of, what was it? S union H, spades and hearts. So spades and hearts, everything but spades and hearts, well, that's going to be clubs and diamonds, right? That's going to be the complement, everything but those two things. So that's going to be clubs, uh, union, diamonds. Okay. F says, is the state the number of elements in S plus the number of elements in H equal to the number of elements in S union H true? Well, in this case, it is true because you've got these two different sets that they don't overlap at all, right? So if I add those together, that's just going to give me the total of the two of them together. Well, hopefully that made sense. So yes, because they don't intersect. All right, moving on. Okay, so it says the athletics department at a large high school offers 16 different sports. So there's all these sports, right? These are all different elements. What we're going to be interested in is the number of these elements as we go on. So it says using set notation and or Venn diagrams, determine the number of sports that require the following types of equipment. So a ball and an implement. So stick, club, racket, yada yada. Okay, so what I would do is look at page 26 while you're going through this as well. That's gonna be kind of helpful for you guys. So yeah, um, actually, you know what I'd like you guys to do is go to page 26 for this one, and the answer is there. Like the answer is like on the pages there. I'd like you guys. It's a little bit different, but I'd like you to go through and fill this out with the textbook, so you can kind of like use their kind of set notation and see kind of what they're doing, kind of interpret what they're doing. They got good graphs and stuff on there. So you guys go ahead on page 26 and do that one on your own and do the Venn diagram. Okay, and example 3 now. This is similar to actually the last lesson that we were doing too, lesson 1.2. So I'm going to let you guys do this. It's also in your textbook as well too, so you can follow along with that one. Okay, so same with this question. I'd like you guys to go through this one. What I'd recommend is just kind of do the question on your own and kind of see where you think Tyler made the mistake there. So yeah, that's going to be it for that. When you guys are done that, make sure that you do the next questions, please. So I'm going to end that video there.